Hello, everybody, and welcome to Pisa Presents with Still Extinct. Now, this is obviously in homage to the recent Time cover on the direwolf, and this whole entire thing is on direwolves itself. Now, okay, so things have obviously gotten a bit complicated with them recently. Now, with these in general, I do try to do these a couple of weeks or so in advance. And originally, this was, in particular, the exact original photo I had chosen for this one when this was done a couple of weeks ago and entitled Dire Wolves in the Fossil Record. The thing was all set, done, everything was put together. I'm like, you know what, this is cool. Wipe your hands of it, it's good. When whatever day it was that the news broke, April 6th, April 7th, whatever that was, my husband had on, I remember, Batman Forever of all things. And he's just going, what's this about the direwolves not being extinct anymore? And I'm like, what the heck is that? Like some sort of stupid, like, Riddler question? Like, what the heck are you talking about? And he just goes, no, it's all over the news. This company said that and I remember him squinting at his computer screen and he just goes, somebody said that they like de-extincted the dire wolves. And yeah, so let's go take a look into things really. But the question is, so riddle me this, Batman. When is a direwolf not really a direwolf? Well, spoiler alert, when it looks like that. So let's look into really what a direwolf actually was, and also too into the ongoing controversy because heaven knows this entire situation has blown up like anything about the de-extinction ongoing, whether or not it is or it isn't, of the direwolves themselves. So the direwolves came about in North America during the Pleistocene. Now, that in particular is their family. Altogether, said family includes 13 or 14 genera. Now, this becomes important, I swear. So now I'm not going through like an exact family tree of every single canid, but still. So you have two genera that we're going to be looking at in particular, Enoscion and Canis. Now, two very important species that we're going to be concerned with, folks, are Enoscion dirus and also Canis lupus. Now, respectively, those are the direwolf and then the gray wolf. So there are two subspecies of the direwolf, A. dirus dirus and A. dirus gildei. Now, Enoscion dirus is also, well, obviously the direwolf, but it's previously called, just so that you're aware, when you see the name Canis dirus in literature or websites, what have you, that is actually its old name. It was changed around 2021, which was a huge year for direwolf research, absolutely massive. It's really amazing how much of these animals that we know about and how much of that has really only been uncovered in the last few years. But we'll get into some of that in a little bit. But yes, the name was changed because of basically uncovering more about the direwolf genome, and more or less they found out just how much it was not related to the canids. So because of that, it was changed from Canis to Enoscion. Now, altogether, you're looking at an animal that's about 125 to 175 pounds and roughly 3.4 to 3.8 foot tall at the shoulder. Now, they were first found in 1854 in Indiana. And I am very sorry, but with the White Walkers, really, you're not looking forward with anything coming north right here. So there are only 5 unconfirmed reports of the direwolves north of 42 degrees. And again, I emphasize unconfirmed. That's another thing that is very important, in fact, crucial to this whole entire de-extinction controversy in a very key factor. So now Why is that? Well, scientists basically point to with the main things that they ate, the creatures that they ate, the animals that they ate, that is, simply didn't live in those higher latitudes. They just didn't. So that's why they just didn't find them that much further north. Now, meanwhile, they went further south through Mesoamerica, and then they were also found so far in 6 localities in South America. And however, there is an unconfirmed report of a potential jawbone in China that they were still working on, trying to figure out whether or not that is actually a direwolf or not, because there's a lot of back and forth about these things. Now, this right here, the one on the right with like the citrusy color backlighting, that is one of the most absolutely wonderful parts of an absolutely wonderful place. Obviously, as you can tell from the picture, that's the La Brea Tar Pits. Now, this place, the George C. Page Museum of La Brea Discoveries, is kind of like the central hub that does the museum's research. Now, so they are the main place that does the research on the direwolves, because so many direwolves has been found here. They have the most raw data to work with, the most raw material. So why have so many direwolves been found here? Well, it's just really, it goes into the psychology of how these animals most likely behaved. You're looking at pack animals. So if you happen to be a direwolf, say, just put yourself into their paws, and you're just ambling around and it's the Pleistocene, and you're looking at the Pleistocene equivalent of a McRib just struggling there in the tar, and you're like, that looks pretty tasty. And then you go jump on that little fella right there, and then one person goes to do it, and then pack behavior, not only does Tom do it, but so does Dick and Harry as well. So that's why when you come there, there is such a superfluous amount of direwolf skulls as compared to herbivores, which is not something that you may expect when you come there. And it's actually when people at first were starting to actually explore and chart out La Brea, they were very astonished by the amount of direwolf skulls that they were finding and remains, so much so that they were wondering if perhaps local ranchers' dogs had gotten lost there. But no, it wasn't the dogs, it was direwolves. Now, here is a skull from there. You can actually see it's just from the tar itself, just the darkening that it does to the bones themselves. Now, this is to illustrate one of two key things that people of La Brea have been and still are studying about direwolf skeletons as they age. One thing is the teeth. If you look very closely at the tooth that is pointing at in the back, you can kind of see it's a little bit scruffy looking. It's a little bit broken up. So what they've been able to find is in a lot of dire wolves, adult ones, the back teeth are broken in a very characteristic way that looks like they have been gnawing on bones, very, very large bones. So, because of that, there is an ongoing theory that these animals were not only predators, but potentially also scavengers as well. And also, too, in a very, very large subset of animals that they studied, adult animals of basically, say, middle aged and up, it was found that 7% of these animals had osteoarthritis in their joints. And so, and this was just a recent study, and obviously, this was just a small one of just their specimens that were found there. And it appears, though, that it appears to be in line with other specimens elsewhere. So not only did these animals possibly have arthritis going on as they aged, but they also had these dental issues from gnawing on these bones. Now, speaking of the folks at the George C. Page Museum, they are absolutely wonderful, by the way. You can see them right there. And above where it says Photo Courtesy Alamy, that you can look at, that is actually a little direwolf statue right there at their desk. You may wonder, well, gee, that actually doesn't look much like a wolf, but, well, we'll get into that a little bit later. So now, because of these folks, now keep in mind that the process of fossilization, it's called taphonomy. It's very, very hard on an organism, especially something like when you're being preserved in a tar pit, for Pete's sake. So this is very damaging to the DNA. So because of that, we do not have a complete direwolf genome. We probably never will, even with all the advances in science that we have. But still, between the foundations that this place has laid and elsewhere, in 2021, researchers were able to determine for sure now that direwolves split from their ancestral lineage about 5 to 6 million years ago. So, in other words, the ancestors of direwolves split from that line onto which they were about, say, like 5 to 6 million years ago. They finally diverged. So that's really, while in the scheme of the planet, that's the blink of an eye. In the terms of the evolution of a single organism, that's a pretty long time ago. So direwolves split from that main line of canids actually a pretty long time ago. So then the question begs, well, what actually is their nearest closest ancestor? So, well, turns out it's not even a wolf. It's the jackal, the African jackal. And this is actually something that has been DNA tested. It's been authenticated. For some odd reason, this is one of the things that is getting argued about a lot in the press right now. This is something that has been completely DNA authenticated by multiple researchers at multiple places. The closest living genetic relative of the dire wolf is not the gray wolf. It is first the jackal, and then the African wild dog, and then there is a creature called the de-extinction. And that is it. It is those three. It is actually not even genetically a wolf. How's that for you? Now, why, you may ask, does it kind of still sort of look like a jackal? Well, that all boils down to what's called convergent evolution, friends. So basically, you're dealing with species that, while they grew up in different places at different times, they still occupied relatively similar ecological niches. So they evolved along similar pathways, and because of that, they evolved similar, skeletal characteristics, other things like that. Now, with this whole entire argument with de-extinction and the dire wolves, you can obviously take two parts. Now, the one part is, yes, these are genuine dire wolves. This has been a complete scientific success, or this has been total nonsense. Now, none of the following is to ridicule any of the people that took part in any of this research or any of this genetic engineering, anything that went into this. It's just kind of a quick look into things and just seeing what they went into. But so the company that did this was Colossal Biosciences. Now, as the chief science officer, as her title goes, she's saying we are using the morphological species concept and saying if they look like this animal, then they are the animal. But I would beg to differ, respectively, as we'll look into this, is what they created, does it really look like the dire wolf? Because as the curator of the Brea tar pits adds too, is that there is a lot of public concern over reintroducing a quote-unquote extinct species that is based off of a gray wolf into the territory of a gray wolf when gray wolves are already struggling in said territory, and the territory is declining and disappearing at an ever-increasing rate. It's just not. And plus, two, do you really expect these two species to just magically start linking paws and singing Kumbaya together? It's not going to happen. Now, so how did all this come about, really? Well, in 2021, Colossal Biosciences was founded by these two gentlemen, George Church and Ben Lamb. This whole entire process involves a form of gene editing called CRISPR. Now, this is not only something that they're going to do with various genetic engineering, bringing back extinct species, de-extinction as it's called, but this is also a way that people are hoping to do things with certain diseases that are affecting mankind, like Alzheimer's is one of them. I actually know somebody personally that is involved in Alzheimer's research, and this is one of the things that this individual's company that she works for is looking into using. So, this is a technique that has many, many applications, not just things like this. So, Colossal has been involved and is doing work in bringing back the dodo, the mammoth, the passenger pigeon, the Tasmanian tiger. They've even created something called the woolly mice, which was kind of like a stepping stone onto the mammoth. I would have liked to have shown a picture of that, but sadly I couldn't find anything that was a public source image, but just Google woolly mouse. Now, the question is this entire thing really, is this a new concept? But really, it's not. Now, so in 1962, I believe the year was, it was Watson and Crick. Now, the two guys, along with Maurice Wilkins, and then really it was also Rosalind Franklin, should get the credit too as well for coming up. Well, obviously, she should definitely get a lion's share of the credit, but it was the coming up with the double helix structure of DNA. And so I only mention this because when, oh God, maybe like the mid late 90s, I was actually in AP Bio, and one of my classmates, it was either her grandfather or her great uncle, actually was James Watson. And he came in and he taught our class on DNA. And because, I mean, Jurassic Park only came out in what, 93? So it was still, I mean, this was something at the forefront of really my generation. And so people were asking Mr. Watson questions about this. And, well, do you think that this is really a thing? Do you think that this is like applicable? And he actually laughed and said that at the time when this whole entire the double helix news broke, he even said that they were getting questions from people asking if they could like clone them dodos and get them pet dodos and things. And so, no, folks, this is not a new idea. This is something that has been around for a while. It's just the mechanics are getting a little bit different, that's all. Now, so the key thing is, though, is de-extinction the answer? And that's what a lot of people are arguing. Some folks are arguing that is it better to work on preserving and helping the species that we have here instead of trying to bring back the species that are already extinct? So I personally, instead of just say like speaking on behalf of the club, just me, myself, I do think that it's a better use of resources to be working on the species that we already hear, that are already here. And I actually even remember Mr. Watson himself said the same thing, not to speak for him either, but still, he did say that too. Now, whether or not you say that, all the power to you, but different strokes for different folks. Now, this cladogram right here shows you again the nearest related relatives to the dire wolf. So, this is again, you have your African jackal, African wild dog, and then this little fellow up there, and then you have the regular members of Canis, which again, this has all been DNA authenticated, everything else. So altogether, the dire wolf went extinct about 10,000 years ago, and they branched from these relatives 6 million years ago. So that's why you have so many branches in between. I mean, there's been a lot of time for things to diverge apart. Now, okay, so the question then buggers, why the dire wolf? Well, Colossal Biosciences gave a couple of reasons. And yes, let's just trot the big white elephant out into the room. One of the big reasons was Game of Thrones. And that's one of the big bugaboos about this entire issue is that you can't escape it. And one of the major reasons about this animal coming back, so to speak, was a fantasy-based TV show centered around a bunch of dragons and Peter Dinklage. And as absolutely awesome sauce as Peter Dinklage is, and well, still, it's a couple of people do have a lot of problems about that. And so it's just one of those things that a couple of folks just have it in their craw that they don't like it, that a few folks decided to bring back the direwolf because it got famous in Game of Thrones. So there's that on one hand. Also, yes, too, there is the great role that wolves have in indigenous culture and religion, which, honestly, I respect that. I give great props to that. But still, all the same, not being indigenous myself, not having that honor, I still give great props to that reasoning. But still, what actually did they do? So this is what physically happened. Once they made the decision, you know what, we're going to bring back the direwolf. What did you do? So over 9 months, they sequenced DNA from an actual direwolf fossils, mind you, an actual 13,000-year-old tooth, and an actual 72,000-year-old inner ear bone. Altogether, these fossils were around for roughly, the species was around for about like 150,000 years, give or take. Now, so that is not a dire wolf. That is a gray wolf. So they used a gray wolf as a base or a surrogate off of claims that they are the closest genetic relative, but ding, ding, ding. Of course, they are not. So, key issue number one with the entire process that a lot of geneticists, molecular biologists, and paleontologists are having, because there is a very, I'm trying to find a very polite, non spicy way to say this. There is a very consistent argument in some sources about kind of like denying the existence that all this genetic research has been done, verifying that their closest relative is the jackal and not the gray wolf. Their closest relatives are not the gray wolves. By far and away, they are not the gray wolves. Now, a gray wolf has 2.5 billion base pairs of genes, billion with a B. Just think about that number in your head and just let that sit for a second. Now, okay, so shift to the left a second there. So genetic comparisons were made. So they looked at the DNA that they had from the direwolf and they compared it to a very, very limited section, basically, of the gray wolf. And they took 14 genes of the gray wolf and they made 20 changes off of those 14 genes based off of what they felt the direwolf would look like. So in other words, they did not add any direwolf DNA into the gray wolf. No DNA was spliced into it. No DNA was added. This was not a clone. This was not anything like that. They merely modified the gray wolf genome so that it would look more like what they felt a direwolf looked like. Problem being, how can you tell what a direwolf looked like? And also, too, a very, very key problem is that you've already made a very crucial mistake in assuming that their closest relative was the gray wolf. It wasn't. You're making a very, very key assumption off of just, well, a very key mistake in doing this with gray wolves instead of with the jackals or the African wild dogs, for example. Now, another one is that they did these, if anybody's seen the pictures, all of them are white. And there's been a lot of press about this, about how these were made white purposely and about all of the care that was done to be sure that these dogs were made properly, the direwolves were made properly healthy and everything, because there are actually genes about the absence of pigmentation in certain canids and about how it can cause certain health conditions. And you know what? That's great that they went to all that work. But the problem is that dire wolves were not likely white. I mean, if you think about it, okay, now, again, just to use a Game of Thrones analogy. So, really, really stupid way to explain it, but it makes sense. So, if like you're all the way up in the north and say like that character Ghost, the white direwolf, that one made sense because it was all the way out in the snow and you couldn't see it that much. But if you're out just on the fields or in the plains and you were an animal that was pure white, you would have stood out like a absolute, I mean, yeah, it would have been like ringing the dinner bell, like trying to keep all your prey away from you. You would have stood out too much. These animals were not likely white. And this is something that quite a few different places that have studied the direwolf have come up with independently throughout the years. Now, the problem is that 5 of these edited genes were edited specifically to lighten the coat. So, again, the argument becomes, while yes, we respect that you did this carefully with the health of the animals in mind, still, you did this also respectively based off of an impression that you had gained from a fantasy TV show. And yes, so did, were the best of intentions gained here? Maybe, perhaps not. So 45 embryos were grown in a North American location, which resulted in 3 pups. Romulus and Remus were born on October 1st of 2024. Bunch of people online I've seen have absolutely no idea of the reference of that name. So Romulus and Remus were the legendary founders of Rome. Their symbol was the wolf. It was basically like if you would name them after some of the Starks, except like the competent ones. So if you had named them like after like Arya or something, like Arya and Arya, if you had just done that. And then Khaleesi was born in January of 2025. And the company insists that the animals are full de-extinct direwolves. But, and again, of course, this is just me speaking and not exactly the club. The problem is that they're not. They're not de-extinct direwolves. They are basically, loosely put, designer gray wolves modified to look like direwolves off of an impression that people currently have based off of what direwolves look like gained from a TV show. And so, an analogy that I came up with this may be weird, but follow me here because this actually worked explaining this to quite a few people at work. So, say that this was Planet of the Apes here. I mean, dead serious. So, say that this was Planet of the Apes and you're like Cornelius or something, and you're trying to bring back humans for whatever reason. You're trying to re engineer intelligent humans, like you want Bright Eyes back in front of you or whatever. So, say that, but you're trying to do it with the chimp genome. Now, chimps and humans are a lot closer related than direwolves and gray wolves are. So, now, do you honestly think that if you took 20 genes out of a chimp and if you altered them, just like 20 random genes, even if you got really, really lucky and you did a lot of work trying to alter them very, very carefully, and you picked ones that made them look really, really exact, and you used like the right type of surrogate and everything, I mean, what are the chances that you would get something that would still look like a chimp? Or would you get something that would look like a human being? No, you would still get something that would still look like a chimpanzee. You wouldn't get something that would look like a human because you would only have changed 20 genes out of several billion base pairs. You just can't change one species into the other and just be, oh, A looks like B, so that means what it is right now. You can't, no, you can't do that. Well, they did, but still, it's not the best way of explaining it. So, yes, I definitely agree with Mr. Schiffman here. These are not direwolves by any definition. So thank you very much for joining us right now, folks. And I hope you have a wonderful rest of your week and have a lovely day now.